Welcome to Notebook 23, Combining Chains. In this notebook, you're going to learn how to compose multiple LLM-related chains together. By the time you complete this notebook, you will learn how to compose chains of chains and also apply your ability to chain meaningful language tasks in a few exercises. We're going to start with our imports. There's nothing new here from the previous notebooks, and also instantiate an LLM instance as we've been doing. Okay, so let's talk about combining multiple LLM chains. If you recall, runnables can be composed into chains, and also that chains are themselves runnables. So therefore, it follows that chains can be used to compose larger chains. It's really easy to imagine tasks where we would like to perform that would require multiple calls to a large language model for the desired end result. So we're going to begin our exploration of chaining chains with such a scenario where we're going to compose multiple large language model chains, piping the output of one of the chains as input into a second chain. So to do this, we're going to work with the following list of thesis statements. And please note, there's going to be typos and grammar mistakes in these thesis statements, and those are put there intentionally. Like here, physics is misspelled. Grasp is misspelled. If you read this carefully, you'll just see it's kind of sloppy. Right? So our end goal is going to be to expand each of these thesis statements into a well-written paragraph. And we want the thesis statement itself to be the first sentence of the paragraph that it's a part of. Now, you may have noticed, though, as we just said, that each of these needs spelling and or grammar fixes first. So the first thing we're going to do is create a chain to address the spelling and grammar issues. And then later in the notebook, we're going to take the fixed thesis statements and pipe them into a different chain, which is going to be responsible for generating the full paragraphs with the thesis statement as the first paragraph. Okay, so we're going to have you get to work kind of right away on this. So to begin, create a chain called grammar chain. We've made the boilerplate for you here. And it should return its inputs, whatever inputs you pass it. However, they should be spelling and grammar corrected when they're returned. So we already have an LLM instance defined above, but you're going to need to create both the prompt template as well as the output parser to include in your chain. And it's a good chance you're going to have to develop your prompt template iteratively. It's been a while since we've asked you to do that, basically since section 1. So we want to revisit the idea and give you some more experience doing iterative prompt developments, which is such a core and essential skill. And please make sure, especially, that the chain returns only the corrected text, which will both be a combination of your prompt, right, which is going to ask the LLM not to generate a bunch of extra stuff, but also the use of a string output parser so that you only get the text back from the LLM generation and not additional metadata. And by the time you're done, you should be able to take thesis statements, which we've defined for you here. You should be able to send them in as a batch to grammar chain, and you should get back a list with the corresponding grammar and spell checked thesis statements. So go ahead and give that a try. Pause the video, and after you're done, come back, restart the video, and we'll look at a solution to this particular task together. Okay, good luck. Okay, so this exercise is largely a review of things you've already learned in the course. However, you had an opportunity to iteratively develop a new prompt. I hope you were successful. Here's how we implemented it. We are taking care here first to create a prompt template where we're very specific that our model should generate only the corrected text with no additional comment or preface. So we say fix any spelling or grammatical issues in the following text. Return back the correct text and only the corrected text with no additional comment or preface. And then we say text is here, and we parameterize text. Now that we have that that prompt template, we're also going to need an output parser, which we define here. And with that in mind, because we already have our LLM instance defined, we're ready to create a simple chain where we take our spelling and grammar template, pipe it into LLM, and then finally pipe it into parser. And with that in mind, we're going to batch it on the thesis statements above. We're going to store the output. Excuse me, it looks like I failed to define thesis statements above. We will store the batched responses in corrected outputs, and if we loop through each of them, we can see that each of the sentences have been both spelling and grammar corrected. So that was successful. Okay, now if you remember, this first exercise is one of two parts of a larger bit of functionality that we're trying to build here. So now we're going to give you a second exercise, which is to create a paragraph generator chain. So the goal specifically is to create a second chain called paragraph generator chain. It should be given a single sentence as input, and it should use that sentence as the first sentence of a paragraph, which it should be responsible for generating. Okay, now please note, this chain should not contain any grammar or spell checking functionality. Right? The work that you just did in the previous exercise, we're going to set that aside for a minute. Okay, this chain you want to be singularly responsible for generating the paragraph using the thesis statement as its first sentence. Okay, you should be able to test your chain again by batching it with thesis statements above. Just calling this out explicitly, thesis statements above is still not spell checked and not grammar checked. That's fine. We're not going to worry about that now. We've set aside that functionality until a little bit later. But you ought to be able to batch your new paragraph generator chain with thesis statements and get back a batch of paragraphs that contain the thesis statements as the first sentence. It's very similar to the exercise you just did. It's going to require you to develop another prompt iteratively. So please give that a go and then come back and we'll look at the solution together. Okay, hopefully you were able to pull that off. Hopefully now the process of developing these chains is getting a little more quick, right? You're getting a little more used to it. Here's our solution. We're going to begin by engineering a prompt. For us, we said generate a 4 to 8 sentence paragraph that begins with the following thesis statement. Return back the paragraph and only the paragraph with no additional comment or preface. And then again, we provide the thesis statement here as the parameter thesis. We then create the chain, passing in our new prompt template, followed by LLM and parser, and then we batch it with the original thesis statements. This one's taking a little longer because it's generating full paragraphs. If we look through the actual paragraphs, you can see that it seems to have done a pretty good job. And if you were to look really carefully, I think this is interesting. That even though we didn't prompt the model to address spelling and grammar mistakes, it did fix some of the spelling mistakes anyways. However, it's clear that most of the grammar errors, especially from the thesis statements, are still present. So, that's just kind of interesting to note, right? Is that a large language model might fix spelling whether you ask it to or not if you don't specify. But in this case, at least, it didn't also fix the grammar mistakes. So that's where we're at right now. Okay, so now we're going to move directly into creating a chain of chains, okay? And given what you know about runnables and about chains, we're hoping that you can do this without additional kind of scaffolding from us. So as a third exercise in this notebook, reusing the chains you've already created, right? You're going to create a third chain called corrected generator chain that uses the LLM first to perform spelling and grammar corrections on thesis statements, before then generating full paragraphs based on the corrected thesis statements. Okay, now you don't need to overthink this, all right? Just remember, chains are runnables and can be piped together just like any other runnable, okay? You should be able to test your chain out by sending it again in batch, the thesis statements, but this time the results should be grammar and spelling corrected thesis statements that are the first sentence of larger paragraphs. So give that a try, and after you've given it a go, or if you get stuck, unpause the video and we'll look at the solution together. Good luck. Okay, so here's our solution. all we have to do is create our larger chain. All we have to do to create our larger chain is to pipe together the two chains we already created. So as specified, we're going to define corrected generator chain. We're going to take our grammar chain, which we've already created. And you remember this outputs strings, and we're just going to pipe that directly into a paragraph generator chain. So now we have our corrected generator chain. For the sake of interest in learning, let's again use our getGraph method here and take a look at this longer computational graph that's been created by chaining together these chains. Right? We take a prompt input, which is going through a template. It's going to our LLM instance, and then through our output parser. It results in a string output parser output, which is then getting passed again into a chat prompt template, and then into chat NVIDIA instance. Again, you can see we've used our LLM twice for two distinct bits of functionality in this larger chain. This output is then output parsed, and we end up with a string output. As specified, we are now going to use our corrected generator chain to batch the thesis statements. And if we look at the paragraphs that were generated, we can see that it did exactly what we wanted it to do. But unlike when we did not do the spelling and grammar check first, you can see that this time our thesis statements have been totally spelling and grammar checked. So the main point being is that it's very common to want to compose chains of chains. And one thing I'll mention before summarizing is that, you know, this kind of goes into modular coding practices in general. For this particular chain, for example, we very well may have made the choice that we just wanted to create one chain, right? We wanted to create one chain that was defined in one place and just reuse that one chain for that one bit of functionality. And frankly, that might make a lot of sense in a lot of different scenarios. However, we might imagine a situation where, for example, the grammar and spelling chain, right? Maybe we want to reuse that in a bunch of different contexts, right? So we would like that to be an isolated kind of single purpose bit of functionality that we can import and reuse in all sorts of different kinds of situations, right? And by creating that one kind of reusable single purpose chain, we can then chain it together with other bits of functionality, but still be left with kind of this modular, single purpose, reusable bit of functionality. So not only is chaining chains together something that's important for driving towards the kind of functionality that you ultimately need, but it can also be part of a larger set of best practices in your code, in your programs, in your applications that promotes the reuse of smaller bits of LLM-focused functionality that you can reuse in a variety of contexts. Okay, great. So in the next notebook, we're going to continue on the theme of chain composition, but this time we're going to look on how we can create and utilize chains that have some of its functionality that are performed in parallel. Okay, I'll see you in the next notebook.